Yeah, I'm starting this off. I have about a 2-minute presentation here. I'm just going to go through some of the members, and I'm going to hand it off to actually Dave Van Duzen, and then he's going to hand it off to Siegmeyer. So next slide. So here's a list of our state teams. We have 2 adjoining states, representatives from Michigan and Wisconsin. Of course, we have Illinois, Missouri, and California. And I won't go through the names, but they're up there. This will be posted later on the website, so if you want to know who's on our team, that'll be up there. Next. And then the geotechnical associates. I'll just pause for a second so you can read some of the associates there. Hires, different universities, and such. Reclamation team, which is part of our team. It's kind of interesting that Barry talked about Cold Central plant, but we have a recycler in our team. Next. And then finally, here's some of our friends. So we have some of our staff, different professors and such, internal staff. I'll pause for a second, and Dave, why don't you start the presentation?
Okay, you want me to help her now?
Sure. You can help. Thanks.
Is this working? Bob, do you mind if I stand behind and look over your shoulder?
Cut it out.
All right. I'll try to face the audience once in a while. Okay, just want to point out that this is just kind of a construction overview, and the projects we built for the Geotech team, along with every other project we built last year, are supporting long-term research contracts. And the folks that are working as the principal investigators on the geotechnical team's test sections, Boris Eaton from Iowa State University and Sohail Nazarian from University of Texas El Paso. Just wanted to mention those folks. They'll be giving much more detailed presentations either today or tomorrow. I think it's more likely tomorrow. Next slide. So this is just a brief update on the 2017 NROAD construction. I'll talk about the large stone sub-base sections and the recycled aggregate base sections. What we observed during construction, some changes we had to make, and so forth. And then we also did a lot of geotechnical field testing with FWD and other types of devices, and we'll go into that a little bit. Next. Glenn already mentioned it, the NROAD construction report from last year's construction work is now available for download on a couple different websites. It's on the NROAD website. And basically just a comprehensive report on all the cells that were constructed. We've got some as-built information in there, concrete thickness primarily, and a lot of observations and so forth, talking about the objectives of each project. So it doesn't go into any early performance data. We wanted to get something out quickly so that we get it documented and be able to move on to the research. Next. Get rid of that login thing.
Yep, try it.
Okay, this map might be a little hard, but hard to read. We're looking at primarily the red and the yellow stripes there. The red ones are the recycled aggregate base sections on the low volume road, and you'll notice a gap between that. That's a section that we left in place. The red stretch that's towards the left of the screen is the half of the recycled egg base, and we've got the section we left in place, and then we got the other half of the recycled egg base. And keep in mind that separation is important, and I'll raise that the importance in a minute here. And then the yellow stretch there is the large stone subbase. Next. So the objectives of the large size subbase were basically to test a soil stabilization technique that I believe is primarily used by Wisconsin and Missouri and Illinois as a way of traversing over soft soil conditions that aren't necessarily excavatable or not type of soils like organic soils where you definitely want to get them out of there. by virtue of the sort of the load-bearing capacity of large material. And we're talking 8-inch, 5-inch minus material from a primary crusher and a quarry, placed over soft earth that you otherwise normally wouldn't be able to get construction traffic in, or you can't dry it out, what have you. So that was sort of the gist of this experiment, and comparing two different thicknesses of that large size subbase, both a 9-inch and an 18-inch section. And okay, next one. So this just shows the design details for each one. All four of these sections, it was originally envisioned to have four. 127 and 227 are the two 18-inch large size subbase sections. Everything, all four of these have 3.5 inches of hot mix asphalt, same type of hot mix asphalt. Typical level 3 mix that might be used on a low volume road with a 58 minus 34 binder. That would be representative of what we'd use on a reconstruction type project. Then 128 and 228 were the 9-inch sections with the same thickness of aggregate base and hot mix asphalt on top. You'll notice on the right side of the screen there, you can see a note that says 8-inch PVC. We put that in there because of existing moisture problems that we've had throughout this area over the course of many years. Keep in mind that these sections, the basic footprint or roadbed has been in place since the early 1990s and gone through several iterations of various test sections. A lot of them have been plagued by moisture conditions, and we want to kind of blow out that intermediate ditch and get some positive drainage there. So that's why we put that in. Next. All right, so the big effort in this construction of cells 27 and 28, the large stone subbase, was to create this weakened subgrade condition. I don't have any slides showing when we removed the pavement, what the subgrade looked like, but it was very compact, very stiff, and well below optimal moisture. So we actually had to work quite a bit to get it to a condition that met the requirements that the Geotech team wanted to create. And basically, it was a performance requirement to add water and rip the soil and allow it to marinate in water to get it down to a penetration index between 2.5 and 3.5 inches per blow over the top foot. So you can see the dozer in the background there with the teeth tearing that grade up, and we used off to the left there was a water jet normally used to spray liquid mulch, grass seed, but we filled it with water and we're squirting that out over the roadbed. And you can see also on the right, the long white tube there is the 8-inch PVC drain. Now you could ask yourself, why do we need 8-inch PVC drain? During construction, this became known as Van Dusen's folly. I don't know. It looked bigger in real life than it did on paper. Just saying. All right, next. All right, and this just another shot. So we had good cooperation from the weather with some rainy days and allowed it to soak up moisture after it had been ripped. Next. This is the video. If we can play this. I hope it works. But this is Mike Vertis. And if he did one thing well that summer, and he didn't, this would be it. So is it working? Of course it's not going to work. So over the top foot, 2.5 to 3.5 inches per blow. So you can see a piece of electrical tape on the shaft. That's actually a little too soft. That's about 4 inches per blow, but when you're wading up to your ankles in goo, you tend not to get too persnickety about things. I hope everyone's okay with that. But we tested many different points. We tested points that looked like they were too weak, too stiff, and we had the contractor. They were very willing to work with us in preparing it so that we achieved, by and large, the conditions that were being sought. Next. And started on east end, this is the 9-inch section, and we actually started up on the far east end. You can see a little layer of the large stone subbase. And one comment about this, while it did meet the spec, the spec was written in such a way that this was kind of like a borderline meeting. It was kind of on the fine side of the specification. We decided that it would meet the objectives of the experiment and proceeded with it. But even on when we first started pushing it out from the existing pavement on that far east end, we started noticing some issues with pumping of the subgrade soil. The subgrade soil here is what we call a clay loam. In AASHTO, we use it's an A6 unified. It's a CL. What is that? A lean clay. So regardless, we kept going from that easterly direction towards the west, pushing it out gradually with dozers. We started noticing problems, with all the repetitions of load trucks coming out. It really started getting a little rough looking. So we started approaching from just a little ways down when we had a crossover, and that's what you can see in the foreground there. Next. And after it was all completed, with all the trucks running on it, this is what we ended up with. You can see puddles of goo oozing up through the voids from the subgrade soil underneath. And if you, maybe if you were out there, you would have said, this is it, we're going to stop now and regroup. But that's not what I did. Next. So, and this shows just another view. You can see in the foreground here the wet puddles and the kind of contamination coming up from underneath. And then just sort of towards the top of the slide, you can see a fairly solid line where you don't see the puddles. That's the break line between 27 and 28, where it switched from 9 inches to 18 inches. So one other thing, one of the cell 27s, the plan was to put this 18-inch layer, total layer down in 2 lifts, 9 and 9. But we opted, basically, instead of having 2 subsections there, we've got one 18-inch section. Because of the problems we observed with the 9-inch, we felt that doing a 9 and 9 probably wasn't going to be beneficial for the project. So, and actually it was softer on that far west end. So I won't say what we did. We actually paved the first lift of asphalt on that really weak layer. That was a mistake. Within a couple days, we decided that we were going to tear that out, and we redesigned the sections with John's help and the Geotech committee. And this just shows that at the bottom of that large stone subbase, about 9 inches down, there was still some of the rock material embedded into the clays and subgrades. So it actually did penetrate down underneath and become intermingled with the subgrade soil. Next. These are the redesigned sections. John worked with Tensar and graciously donated some biaxial grid and a triaxial grid. What we did is we had to leave the part that's circled in red is the original cell 228. We had to renumber them because our numbering system and the database and so forth. But that was left in place because at that location we had a very high voltage power line buried there, so we didn't want to disturb that anymore. We left it in place, and we ended up with the gap there. We ended up creating 4 new subsections. So we've got 4 different combinations. Reinforcing grid all by itself, and then a reinforcing grid with the separator fabric. And 2 different types of grid, as I mentioned, a biaxial and a triaxial. Okay? And this just shows placing the large stone subbase over one of those combinations, the biaxial grid and separation fabric. And it was like a difference between night and day, as you can probably imagine. There's no intermingling or pumping of the subgrade soil underneath. One thing I should have mentioned, after we removed the first sections, we did do the scarification and moisture conditioning again. So we got it all gooey for this iteration. Next. And This is a life-threatening close-up. I did have a hard hat on. Next. Recycled aggregate base, so that's it on the large stone. All throughout these, when we got to various points, in hold points within the construction, we were out there doing moisture testing, nuclear density testing, FWD testing. I'm going to forget a lot of it because it was over almost a year ago. DCP, air permeameter, etc. And these data, plus all the performance data that we've been collecting since we've been trafficking this section, will be provided to Sahel Nazarian and Boris Eaton for their research projects. All right, the recycled aggregate base sections basically were conceived to study the relative performance of different types of recycled material. We looked at 200% crushed concretes, one of sort of a coarse 1.5 inch minus, and then another one with our standard gradation of 1 inch minus. We also looked at a limestone, a crushed limestone aggregate base, and then a blend of crushed concrete and recycled asphalt pavement. And the goals are to compare the performance. These are all on similar sections. One thing I want to point out, like I mentioned, there's a gap in these sections. The westerly 2 sections actually have a sand subgrade, whereas the easterly 2 sections on the other side of that area that we left in place are on the clay loam subgrade. So we deliberated over that in the committee meetings, and that was the real estate that we had to deal with. So that's just one thing we'll have to take into consideration when we're looking at performance data. So this is kind of a provide support materials and performance for mechanistic empirical design, and at the very least to compare the performance of 100% concrete in 2 different gradations to other more conventional type of recycled aggregate gradations. Next. And all the bases were placed in 1 12-inch lift, and with 3.5 inches of the super pave level 3 with a -34 binder. And as I mentioned, the subgrades on the 2 185 and 186 are more of a granular subgrade. 188 and 189 have the plastic clay loam subgrade. And we did have the subgrade subdrain towards the median ditch in these as well. Next. And these sections, obviously we didn't try to create, like we did in large stone subbase, a weakened subgrade condition. So this is more conventional construction where we had specified density, trying to achieve normal quality compaction on a subgrade. This cell 189 is the this is the concrete wrap blend. Next. This is the crushed limestone quarry material. Next. And this just shows the subdrain being installed in the sandy area. Next. As the concrete, Brett Troutman mentioned, we installed lots of sensors in many of these sections. And this shows the sections that University of Texas El Paso was partnering with us on. They were working on the recycled aggregate bases, and we'll hear more details about that, but we helped them install their sensors, geophones, and pressure cells. And then in addition to that, we installed temperature trees, thermocouples, and pressure cells, strain gauges, moisture cells, etc. Next. And this just shows one of the devices we used in our Geotech point testing. It's the air permeameter test being done. Next. And University of Texas El Paso they brought down an intelligent, or brought up. I think it came from Texas. I don't know where it came from, but instrumented roller to use to test their geophones that were embedded in the base and subgrade. Next. And to wrap it up, just wanted to acknowledge, obviously, all the state sponsors, associate members from industry and academia and consultants. We had a lot of help from the Golden Valley resident office. They administered the contract, really good people to work with, and District 3 always provides great assistance from surveys and maintenance and materials. Our prime was McCrossin, and then also Tensar. Next. And that's that. I don't know, John, you want to add anything?
We're just interested in having maybe questions asked those. It's going to be great. One just clarification, as Dave mentioned, the report that's being produced by that's actually the team of Iowa State University and the University of Wisconsin at Madison. They're doing the long-term research through the co-PIs on that. And then Dr. Zarian and UTEP, they're a partner with this HRP project. They're producing a report. And then also Dave White with the Geos, his report on the construction testing that was done last summer with both the intelligent compaction roller and then his automated plate load test. That report has already been posted on the team website. So if you're interested in seeing maps of these sections that Dave just described, they're there right now. You can pull it up and look at it, see the differences in the compaction, the stiffness values that were measured last summer. So that's a great report from Dave White with the Geos. So with that, if you have any questions about this week, Gary and Dave and I are here with a few minutes left. If you'd like to ask something about anything you just heard, we're happy to do that.
Yes, over here.
When you put down the 18-inch as a limit, you have to put 300 feet or is that?
That was successful. So the 18 inches of rock was able to bridge that saw separated. And then when we got to the thinner one, and that's typical. I mean, that's sort of that 18 inches. That was the pretty much a typical design that we understood had been used with success in both Wisconsin and Illinois, essentially also. That, again, with the DCP penetration rate that we built, that was the expectation that 18 would be enough. And we could have, we pushed the limit obviously too far with 9. Maybe we should have tried 12, something. But as it worked out, I think it's great because now we did get a chance to look at the effectiveness of these grids, either with or without separator batteries. So it turned out we got another research project that we didn't intend, but that's going to be very, very useful probably going forward. So to your question, the 18 was fine. Less than that is not going to be enough with this soft separator.
I have a question or two. I have actually 2 questions. Is the plane falling? 8-inch? How's that working out?
Well,
I inquired as to the performance this spring with our resident expert, Glenn Bell, and he said he didn't see squat.
And then just one more quick on marinating soils. I really like that. That's great answer. Well, let's thank these guys. Next speaker, great guy. Jerry's been with MnDOT for many years, and both Jerry and I have common former employees. We were both worked at Federal Highway Administration, Minnesota Division for several years together. I came over first, and Jerry said, I told Jerry it's a fun place to work, so Jerry came over too. So Jerry's doing a great job with the preventive maintenance team. A lot of stuff going on in this area, and the way budgets are stretched, obviously, this is an area where we're going to be doing more issues. So, welcome, Jared.
I'm going to talk about the preventive maintenance team and the projects that we're working on now. First, a quick little outline, and I'm glad Barry mentioned it. I'd like to touch on it too. That take a look at the web page if you don't go on too often, especially when you see the appointment come up on the calendar. If you get a chance, 15 minutes before the meeting might kick off, go ahead and look up there. We got all the notes, a lot of information on the projects, schedules, interim reports, and things. So all that's available on the web page. So I'm going to go through a members list and email the team. So when you're on the web page, if you'd like to see who's on the team, that's available there. It's a nice, almost a one-page printout. And you can also email the team, so you can ask a question to the group at any time. And I really think communication is the key to our group being successful. And use the contacts, the people we talk to the next couple days. That question pops up in your head, you'll know who to ask, and learn an awful lot of new things. DOT members are listed here. We really got a great group working on the preventive maintenance type areas from across the 6 states, including MnDOT, that are in the NRRA. And you always want to put a face with the names of the people that are on our team, and we can all do that over the next couple days. Industries involved, and that's really what I think is great about the NRRA, is that we're getting all the experts that are in this room. And I always like to say, like to try and hang out with people that are smarter than I am. That's how I learn some stuff and learn new things. Write down questions, get answers. There's just a tremendous amount of knowledge that's in this room today, so take advantage of it. Also got a great group of friends and support. Federal Highway, Renee Keel's our SRF consultant that's working on some of the projects. Joe Corzelius, also our main pavement expert on that team, is here with us too. Okay, the first long-term research project that we're working on is kind of called Maintaining Poor Pavements. What we're really talking about here is that DOTs all have an awful lot of low-volume roads, whatever your number might be for low-volume roads, and how do we really maintain that? How can we bring back a slight ride improvement? How long will it last? What will it really cost us in maybe dollars per lane mile per year, to make that improvement? So we don't have the dollars to always go out and do the reclamation or the CIR, some of the good things we're trying, but what can we do with a thin lift or scratch course, microsurfacing, kind of scrub seals, help get the ride improved and maintain it there for a few years. Right now, the task that the consultant's working on is really to collect the data from the NRRA states. So you'll probably hear from our consultant fairly soon if we haven't sent it out already. And the important part is if you've had some projects, if you have some examples, and it'll take a little time to gather that information and send it in, but I really think that's going to be an important part of getting this information and kind of getting the results toward the project. Up at MnROAD, as part of this research, we took 2 of the cells on the main line, which is actually kind of high volume, but that was the real estate we had available, and we did some scratch course with, we actually did a 3/4 inch micro mill, and then on half that section we did a microsurfacing, and on the other half we did a thin lay, a thin asphalt overlay. So we've taken roads that had poor ride and we've improved the ride, and now we'll be able to see how those different sections perform. And the difference in the two cells up at MnROAD was one of them was a original about a 6-inch hot mix and granular material. The other was original full depth pavement. So they were old cells, and we helped improve the ride. And now we'll see how long those last. So when you hear from Joe Corzelius looking for some information and data from some of the projects and results you've had, if you got a little case study, a little 2-page write-up or something, please send it in. The second one is we did some concrete joint repair. That's on the old westbound interstate. So partial depth repair for challenging conditions. What the team was really looking at was here that a lot of times you might just have small spall, a couple areas that could really use repair, and you're not going to be letting a big CPR project. Is there something that a maintenance team could have in their truck and stop and mix it up and put it in a hole and kind of get out of there, repair that corner break or a pop out, and get it in there and stay in there for 3 to 5 years. I think if it stays in there that long, it'll probably stay a little longer. But then at some point in time, you'd come back and you do the typical MnDOT type of CPR work where we mill out the spall areas, we do our patching, we do our diamond grinding, we've done the really top of the line long-term fix. So this is what type of materials, maybe there's new materials, we've got things in there that don't have any cementatious material in them, so we've tried, I think we've got about 15 different cells of materials out there, epoxy, kind of an aqua patch type material, you know, hot mix, just add water and pack. So it'll be interesting to see how these all perform, and we'll be talking about that in our preventive maintenance team breakout. So a couple of the tasks that are started on this project, we've got a good summary. Actually, Dave Van Duzen did a terrific summary too in that construction report that's been mentioned a couple times. So all the different cell materials, the spall materials that were listed are all in there. We're working on a survey and literature review, and we're also, as part of this project, are going to have an annual summary of the condition. So I think probably this summer, July, August, we'll have the first year of performance of really, you know, what materials are in there. Did we have any that have come out yet? And I think we can even cut up the ride to get kind of some ride data, because when you are putting materials in a hole and you don't do all the grinding and other things, it is important to get those as smooth as you can. So this probably next couple of months we'll get our survey and literature review done in the annual condition report. Short-term synthesis work that we're working on, and I think these are coming up in fairly soon. So we have one consultant, SRF, is also doing our short-term synthesis project. You mentioned about each of the 4 teams had 2 top priorities. So we're going through all those, the longitudinal construction joint and hot mix and the tack coats were kind of the first 2 that were started and are wrapping up, and as each one of those gets done, we'll get into the next one for the rest of the teams. Surface characteristics of diamond ground concrete surfaces was listed as the first group from the preventive maintenance team about what's out there, what's available, what can we be doing. I work mainly in the hot mix area, but I know our concrete guys are doing a tremendous job, and I think the next generation concrete surface, the new diamond grinding pattern, is one of the quietest ones ever used out there. So after we do these CPR repairs, we can make, and the grinding's done, it's as quiet as I think you can get a pavement, so a tremendous amount of work and innovation is going on with the concrete group. So that this synthesis will touch on all these areas on the different grinding and the surfaces that's available, and maybe even some of the results actually from, you know, the DBA measurements. The short-term synthesis technical panel is listed here. I'd like to encourage anyone, if this is the first time you're hearing about this synthesis and you'd like to join, you can email me, and that my email information is also on the website, and we'd be happy to add you to the list. Bob is doing just a tremendous job keeping all this information up to date, the teams, the members, the email groups, and we can always use some help. The second project, preservation of approaches for lightly surfaced roads. We had some locals with our group, so we're really looking at what I say when we're thinking lightly surfaced is it's probably not hot mix asphalt and it's not gravel. It's somewhere in between. Is it the, you know, the double chip seal? Is it out of seal type things that if we want to do even a CIR and put a light surface on there, what type of options are available, the volumes, ADT, design information. So that'll be the other synthesis. And actually this one is probably the least scoped. We haven't dug into this one too deep yet. So our team will scope this out a little, and we'll decide the way we'd like our consultant to move forward as we discuss, you know, approaches for maintaining lightly surfaced. I think this ties in a little also with our, you know, maintaining low volume pavements that we got a lot of lane miles out there. We'd like to keep them as smooth as possible. I would say, you know, at the lowest dollars per lane mile per year type of result, the most cost effective. Here's the short-term synthesis members. So if you're interested in joining this team, you can once again email me and we'll put you on the group. Also, when I do get information, even though we're working with a little smaller group on some of these syntheses, I will always send it to the entire team so everyone's kind of up to date and been involved. And, you know, once again, the communications in exchanging information. It's great that we get together once a year here for our conference, but a lot of webinars, but we need to keep our communication moving. I think we're getting close to the end, so that was a quick summary. We got plenty of time before lunch. If there's any questions, I'd be happy to answer them. Comments? Okay, that's great. Thanks.